Today we're going to talk about classification of matter. We're going to be looking at atoms, elements, compounds, and mixtures. Now, if you're teaching this in your class, one thing that you might want to do is get an idea of what your students are thinking about in terms of what these terms mean. And what I would do is ask them to draw pictures. Ask them to draw pictures. What do you think an atom looks like? What do you think an element looks like if you could get down small enough so that you could see them? Draw a compound, draw a mixture. What I like to do usually is do this either at the end of the last class. That way you could do it as like a closure, kind of getting ready for your next class. You want to do it such a way that you have time to look at what your students are thinking. So this year with my 9th graders, we start talking about classification of matter. And I had them all draw pictures, and then we just kind of rotated around the groups, and every group got to look at what other people had drawn out. For my 9th graders, for the atom, I got what I would call the Jimmy Neutron atom. You've probably seen that before. They drew a couple of circles in the middle and some lines like this. And a couple of the students actually labeled protons, neutrons, electrons. For element, I got a lot of stuff that looked like this. So I got stuff like that. I got stuff like this. Okay. For compound, most of my students were drawing this, which many of you will kind of recognize water. A lot of them kind of already know what that looks like in the 9th grade. Then for mixtures is where we kind of broke down. This is all, pretty good. But when we got to mixtures, I got all kinds of crazy stuff there from my 9th grade students. Everything from just a picture of a jar of mayonnaise, so one group drew out, to really I got a lot of stuff like this. And if you just give me a second to draw this out. So that was their mixture, which if you look at that, from us as teachers, basically they were just drawing a larger compound. And so with my 9th graders, we weren't making the distinction of what a mixture was. And so it'd be kind of interesting, something that you would want to do as far as modeling, which is what this is get a notion of what is their preconceived framework that they have about what these things look like. Okay, so I would do that first if I were teaching it. Okay, and then when you come in the day to actually start your lesson, a good thing to do would be to have some examples, some real examples out there. For elements, some things that you could do, you could get a helium balloon. It's a good example. You could get some charcoal. Maybe have a picture of some mercury, because I know we don't have mercury thermometers anymore. All kinds of metals that you can have with your elements. For compounds, you could have a glass of water, maybe some salt, some sugar. And then for mixture, Gatorade, Kool-Aid, something like that. So it's neat for them to come in and kind of look at some things as you get started there. And even the day that you do the pre-model, kind of seeing what they think, you could have those real examples up there. So since we talked a little bit about models and talked a little bit about real examples, I want to just talk about these 3 terms, which I'm going to use a lot in the chemistry instruction. So symbolic for chemistry, basically that is talking about our chemical symbols. It could also be talking about our mathematic formulas. For this discussion, it's going to be chemical symbols. So for a balloon filled with helium, we would write just He, that's the symbol. For a glass of water, we would write H2O, because that's the formula, okay? At the particulate level, we want to start thinking about what are these little particles doing, what do they look like? And typically for the particulate level, we're going to use circles to represent atoms. So for our helium balloon, we might draw something that looks like this. Okay. And for our glass of water, we might draw something that looks like this. At the particulate level. And then, of course, macroscopic would be the actual samples. The actual samples that you have out for the students to look at. You can always have pictures. You don't have to have the real thing. Okay, so we're going to talk a lot in the upcoming segments. Symbolic, particulate level, and then the macroscopic, what you can actually see. So I wanted to take a minute just to kind of break that down. Okay, so now let's go back and start kind of breaking down what these terms mean and looking at some pictures. And so for an atom, a lot of times if you have a students draw pictures of that, they want to go subatomic. So they want to show you protons, neutrons, electrons, at least at the high school level. But for our discussion of matter, that type of model of the atom is not useful. So if I said, okay, let's draw a helium atom, I would draw one thing, because an atom is a single unit, okay? But if I wanted to draw the helium, the element, an element is a collection of all the same type of atom. And so for helium element, I like to think bigger. So let's think about our helium balloon. Let's blow up a little picture here. And so all the same type of atom. They're not connected. They're far apart because it's a gas, okay? And so helium atom, single substance or single particle, okay, and atom, think about that. Element, a collection of all the atoms. Whereas if we had like a lump of coal, right, so this is coal, charcoal, and we blew it up, it would look a little bit different. Number one, it's a different atom, so we don't want to show an open circle. We show a closed circle. And it's carbon solid, okay? So we're going to show the atoms a lot closer together and ordered. And I drew my circle too big. I want to make it a little bit smaller here. So I have to draw so many. Okay? But if we had a carbon atom, we could show that here. And so a lot of times the word atom and element are used interchangeably. Okay? But an atom, think about just one substance. Element, think about something that you can actually see and kind of hold on to, and then you can blow up what those and get a thought about what those atoms are actually looking like inside that element. Okay? And elements that we need to really talk about right now, because this is where the difference comes in, is when you have these things called diatomic elements. So if you think for a minute about what diatomic means, it means two atoms. So there are 7 diatomic elements. It follows a mnemonic called Brinkelhoff. So I'll show you where it's coming from. BR, I, N, Cl, H, O, F. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. All of these elements exist together, okay? So there's always going to be 2 of them there. And so when we get into diatomic elements, you really get a distinction between what your pictures would look like. For example, if I said draw a picture of the nitrogen atom, then you would draw something like this. I put stripes so that I can show it's different from the helium or carbon atom that I have. But if I said draw a picture of nitrogen, the element, in its elemental state, nitrogen is always hooked to another nitrogen. So I couldn't draw a single atom there. That would not be okay. Nitrogen is a gas. So I'm going to show my balloon again and my blow up. Okay? And so instead of showing one separate from all, what I'm going to do is show 2 together. Okay? So show 2 together. So they're actually hooked through a chemical bond. And it's for nitrogen, it's actually a triple bond there. Okay? So atom and element, again, are used interchangeably a lot in textbooks. When people talk, they're used interchangeably. And for the most part, they kind of are. Here, same. But when you talk about the diatomic elements, it's a big difference between the nitrogen atom and nitrogen, the element. So you have to be careful with that. And this is something that you could tell your students about, especially since oxygen and hydrogen are in here, and nitrogen. Those are all some pretty common elements out there. Okay? So that's the difference between atoms and elements. Now we're going to take a look at what the difference is when you have a compound. All right? So a compound is a substance that's made up of two or more different elements. So if I wanted to draw a picture of a compound, I could draw water. Okay, I could draw salt, and so on. So notice these are different elements. They're hooked together chemically. They can't be separated by physical means. So in other words, if I wanted to break apart the O's and the H's here, I can't do this by boiling it or melting it or anything like that. And if I wanted to draw my picture, I would draw an oxygen in the center, and then two hydrogens out to the side. And this time I'm actually using a line to represent the bond that occurs right here. So if you're looking at this as just a picture and not the symbolic, you could recognize this as a compound because there's different types of circles. And so that tells you there's different atoms in there. So that's a compound. NaCl is actually kind of different because it's ionic. So we'll talk a little bit about that. There are positive and negative ions in NaCl. If you have 1 unit of sodium chloride, it would look like this. But if we have lots of salt, where we have lots of these, what happens is all of these ions line up in what's called a lattice, and it just kind of keeps going and going. And it's 3-dimensional. I'm not very good at drawing this, but these are called crystal lattices, and it all lines up, and that's where you get these nice little crystal structures that you see with salt. Okay, and so again, the way I've shown my difference here is I've shown positives and negatives, and so that's how you would know there were different substance or different atoms in this compound. You can do color here too, which I can't with my marker, but that would be another thing that you could show. Now your students, if you ask them to draw this, they're not going to do this. They would probably do something like, color plus, striped, just to show two different things. Here with your students, you should be seeing one thing and then two different, like that. Okay, so those are compounds. And then with mixtures, mixtures are a lot harder to draw up here. And so what I'm going to do now is kind of switch over to some drawings that other people have done and kind of see if you can tell the difference between these things. So at this point, it might be a good idea to pause your video. So based on what we've talked about, can you identify these pictures? Is it an element? Is it a compound? Is it a mixture? So take just a minute, see if you can classify these. Also, as you're looking at these, I kind of alluded to it before, but kind of think about, is it a gas, is it a liquid, is it a solid? Because that's stuff that you want to start getting into with your students as well. Okay, so now you should have had time to identify these. And so if we look at A, we notice everything's exactly the same, red dots, okay? They're not connected, so that tells me everything the same, this is an element, okay? It's gaseous because they're so far apart. Looking at this picture, you can see you have this substance, which is a gray and a red, and then you have this substance, which is just a red, and you have this substance, which is just a gray, and so this would be a mixture. Okay, and this is what students have such a hard time with. They think that in a mixture, everything is connected, And you can show them through some lab work that in mixtures you can actually separate them. It's pretty easy. You can distill Kool-Aid. You can get the water to boil off, and the red residue or whatever color Kool-Aid you use is left behind, so that they can see that the Kool-Aid and the water don't come together to form a new compound. It's a mixture, separate components like I've shown here that can be separated out. All right. This next one you can see is probably a compound. They're all attached together there. Your students will probably look at this and see, okay, there's one substance, right? It's all connected together. Here it is again, but it's exactly the same as this one, so it would be a compound. And be a solid here. This is liquid, solid. This one, we got reds, we got blues. Okay, they're different. So this is a mixture, and it's a mixture of elements. This one, mixture, I forgot to say, elements and compounds. This, definitely a compound. As you can see, all those are touching, all the same, but it's two different atoms. So that's a compound. This one, you kind of start to get the picture. You have this substance, this substance, this substance, compound, compound, element, and there's another element even. So that's a mixture. This, compound, compound, separate, mixture. Okay, so hopefully, looking through those, you got those. You could give these pictures to your students. This came from a website called targetinquiry.com. If you search particulate models of elements, compounds, and mixtures, you can probably find lots of pictures online. You can have your students make their own pictures once you go through your lesson. Look at your previous model. What do you think an element looks like now? What do you think a mixture looks like now? What do you think a compound looks like now? And kind of see where they go. You want to take their model and get them to improve it as they go along. Okay. I think there's one more example. No. All right, so last one, and this is one, not really anything tricky. Here we see again, I'm going to start with this one first. Compound, element, right, mixture, compound, and then here's where it gets maybe tricky. You see that? A lot of times students, especially when these two are kind of given more towards the end, they'll see two things, and so they will think compound, two things, compound. But these two things, these two circles representing atoms, are exactly the same. And so don't forget, when the atoms are exactly the same, it can't be a compound. Compound has to have different. And so this is actually element. And remember, it's one of those diatomic elements. And you can see that here too. And so you can put these pictures with these elements in there to kind of make sure that your students really do understand what the difference is between element and compound.